Chapter 3, Pair of Linear Equations in Two Variables. The topics are Introduction, Graphical Methods of Solution of a Pair of Linear Equations, Algebraic Methods of Solving a Pair of Linear Equations. Introduction. In this chapter, we'll learn how to create and solve linear equations. Consider the scenario. Akila is at a fair. She wants to ride the giant wheel and play hoopla. The number of times she played hoopla is half the number of rides she took on the giant wheel. A ride costs 3 rupees, and a game of hoopla costs 4 rupees. If she spent a total of 20 rupees, how can we find out how many rides she had and how many games she played? Let's break down Akila's problem. First, we assign variables. Let x be the number of rides on the giant wheel. Let y be the number of times she played hoopla. Next, we form two equations based on the information. Equation 1, y equals 1/2 of x. This represents that the number of hoopla games is half the number of rides. Equation 2, 3x plus 4y equals 20. This represents the total cost of the rides and games. Graphical method of solution. When dealing with a pair of linear equations, we can classify them based on their solutions. An inconsistent pair has no solution. A consistent pair has at least one solution. A dependent pair has infinitely many solutions. A dependent pair is always considered consistent. The graphical representation of a pair of linear equations tells us about its solution. If the lines intersect at a single point, there is a unique solution, and the pair is consistent. If the lines are parallel, there is no solution, and the pair is inconsistent. If the lines are coincident, meaning they are the same line, there are infinitely many solutions, and the pair is dependent and consistent. We can determine the graphical representation by comparing the ratios of the coefficients of the two equations, which are in the form a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. For intersecting lines, the ratio a1 over a2 is not equal to the ratio b1 over b2. This gives exactly one unique solution. For coincident lines, the ratio a1 over a2 is equal to the ratio b1 over b2, which is also equal to the ratio c1 over c2. This gives infinitely many solutions. For parallel lines, the ratio a1 over a2 is equal to the ratio b1 over b2, but not equal to the ratio c1 over c2. This means there is no solution. To summarize the conditions for a pair of linear equations, if the lines are intersecting, then the ratio a1 over a2 is not equal to the ratio b1 over b2. If the lines are coincident, then the ratio a1 over a2 equals the ratio b1 over b2, which equals the ratio c1 over c2. If the lines are parallel, then the ratio a1 over a2 equals the ratio b1 over b2, but is not equal to the ratio c1 over c2. Example 1. Graphical solution. Let's check if the pair of equations x plus 3y equals 6 and 2x minus 3y equals 12 is consistent and solve it graphically. To do this, we find 2 points for each equation to draw the lines on a graph. For the first equation, if x is 0, y is 2. If x is 6, y is 0. For the second equation, if x is 0, y is negative 4. If x is 3, y is negative 2. When we plot these points and draw the lines, we see that they intersect at the point 6, 0. Therefore, the solution is x equals 6 and y equals 0. Since there is a solution, the pair of equations is consistent. Example 2. Infinitely many solutions. Let's graphically analyze the pair of equations. 5x minus 8y plus 1 equals 0 and 3x minus 24 divided by 5, y plus 3 divided by 5 equals 0. If we multiply the second equation by 5 divided by 3, we get 5x minus 8y plus 1 equals 0, which is identical to the first equation. This means the lines are coincident, and, therefore, the pair of equations has infinitely many solutions. Example 3. Pants and skirts problem. Kampa bought some pants and skirts. She said, the number of skirts is 2 less than twice the number of pants. Also, the number of skirts is 4 less than 4 times the number of pants. Let's find out how many she bought. Let x be the number of pants and y be the number of skirts. The equations are y equals 2x minus 2, y equals 4x minus 4. To solve this, we find points for each equation and plot them on a graph. For y equals 2x minus 2, we can use the points 2, 2, and 0, minus 2. For y equals 4x minus 4, we can use the points 0, minus 4, and 1, 0. The two lines intersect at the point 1, 0. This means the solution is x equals 1 and y equals 0. So, Compa purchased one pair of pants and no skirts. Algebraic methods of solving. There are three main algebraic methods for solving a pair of linear equations: substitution method, elimination method, cross-multiplication method. This chapter will focus on the substitution and elimination methods. Substitution method. The steps are as follows. Solve one of the equations for one variable in terms of the other. Substitute this expression into the second equation. Solve the new equation for the single variable. Substitute this value back into the expression from the first step to find the other variable. Example: substitution method. Let's solve the equations x plus y equals 10 and 2x minus y equals 2. From the first equation, we get y equals 10 minus x. Substitute this into the second equation. 2x minus 10 minus x equals 2. Solving for x, we get 3x equals 12, so x equals 4. Substitute x equals 4 back into y equals 10 minus x to get y equals 6. The solution is x equals 4 and y equals 6. Example 4. Substitution method. Let's solve 7x minus 15 y equals 2 and x plus 2y equals 3. From the second equation, we get x equals 3 minus 2y. Substitute this into the first equation. 7 times 3 minus 2y minus 15 y equals 2. Solving this gives negative 29 y equals negative 19, so y equals 19 divided by 29. Substituting the value of y back, we find that x equals 49 divided by 29. The solution is x equals 49 divided by 29 and y equals 19 divided by 29. Example 5. Aftab's age problem. Aftab tells his daughter, 7 years ago, I was 7 times as old as you. 3 years from now, I will be 3 times as old as you. Let S be Aftab's age and T be his daughter's age. The equations are S minus 7 equals 7 times, T minus 7, S plus 3 equals 3 times, T plus 3. Using substitution, we find that T equals 12 and S equals 42. So Aftab is 42 and his daughter is 12 years old. Example 6. Pencils and erasers. Problem: the cost of 2 pencils and 3 erasers is 9 rupees. The cost of 4 pencils and 6 erasers is 18 rupees. Let's find the cost of each. The equations are 2x plus 3y equals 9 and 4x plus 6y equals 18. If we solve the first equation for x and substitute it into the second, the variables cancel out and we are left with the true statement. 18 equals 18. This means both equations are the same. Therefore, there are infinitely many solutions, and we cannot find a unique cost for a pencil and an eraser. Example 7. The crossing rails 2 rails are represented by the equations x plus 2y minus 4 equals 0 and 2x plus 4y minus 12 equals 0. Will they cross? Using the substitution method, we solve for x in the first equation and substitute it into the second. This leads to the false statement negative 4 equals 0. Because this is a false statement, the equations have no common solution. Therefore, the 2 rails will not cross each other. Elimination method. The steps for this method are: multiply one or both equations by suitable numbers to make the coefficients of one variable the same. Add or subtract the equations to eliminate that variable. Solve the resulting equation for the remaining variable. Substitute this value back into one of the original equations to find the other variable. Example: elimination method. Let's solve 3x plus 2y equals 11 and 2x plus 3y equals 13. Multiply the first equation by 3 and the second by 2. This gives us 9x plus 6, y equals 33, and 4x plus 6, y equals 26. Subtract the second new equation from the first to eliminate y. This gives 5x equals 7, so x equals 1.4. Substitute x equals 1.4 back into an original equation. This gives 3 times 1.4 plus 2y equals 11. Solving for y, we get y equals 3.4. The solution is x equals 1.4 and y equals 3.4. Example 8. Income and expenditure problem. The ratio of the incomes of two people is 9 to 7, and the ratio of their expenditures is 4 to 3. Each saves 2,000 rupees per month. Let's find their monthly incomes. Let their incomes be 9x and 7x, and their expenditures be 4y and 3y. The equations are 9x minus 4y equals 2,000, 7x minus 3y equals 2,000. To solve this, we multiply the first equation by 3 and the second by 4 to make the coefficients of y equal. After multiplying, we have 27x minus 12y equals 6,028x minus 12y equals 8,000. Subtracting the first new equation from the second eliminates y, leaving x equals 2,000. Substituting x equals 2,000 back into the first original equation gives y equals 4,000. Therefore, their monthly incomes are 9 times 2,000 and 7 times 2,000, which are 18,000 rupees and 14,000 rupees, respectively. Example 9. No solution with elimination. Let's use the elimination method for the equations. 2x plus 3y equals 8 and 4x plus 6y equals 7. Multiply the first equation by 2 to make the coefficients of x equal. We get 4x plus 6y equals 16. Subtracting the second original equation, 4x plus 6y equals 7, from this new equation results in the false statement 0 equals 9. Therefore, the pair of equations has no solution. Example 10. Two-digit number problem. The sum of a two-digit number and the number obtained by reversing its digits is 66. The digits differ by 2. Find the number. Let the tens digit be x and the units digit be y. The first number is 10x plus y. The reverse number is 10y plus x. The first condition gives the equation x plus y equals 6. The second condition gives two possibilities, either x minus y equals 2 or y minus x equals 2. Solving these pairs of equations by elimination, if x minus y equals 2, we get x equals 4 and y equals 2. The number is 42. If y minus x equals 2, we get x equals 2 and y equals 4. The number is 24. Thus, there are two such numbers, 42 and 24. Summary in this chapter. You've learned that a pair of linear equations can be solved by two main methods: graphical method, algebraic method, using the graphical method. If the lines intersect, there is a unique solution and the equations are consistent. If the lines coincide, there are infinitely many solutions, and the equations are dependent and consistent. If the lines are parallel, there is no solution, and the equations are inconsistent. Summary of algebraic methods. The algebraic methods discussed are substitution method, elimination method. The consistency of a pair of linear equations can be determined by the ratios of their coefficients. The pair is consistent if the ratio a1 over a2 is not equal to the ratio b1 over b2. The pair is inconsistent if the ratio a1 over a2 is equal to the ratio b1 over b2, but not equal to the ratio c1 over c2. The pair is dependent and consistent if the ratio a1 over a2, the ratio b1 over b2, and the ratio c1 over c2 are all equal. Thank you for learning with us.